Hey guys, we're talking about confidence intervals. Okay, now let's look at what our objectives are. We are going to have to go back and revisit the 10% rule, the large count conditions, as we construct our confidence intervals. Like I said, we're going to be constructing and interpreting them. And yes, we're going to be determining the critical level C. If you remember today in our project, our Hersys-Kishis project, we determined that Z star was, of 95% confidence interval, was 1.96. And we're going to find that for some other level C's also. So, turn to page 4 of your notes. So as we look at, like I said, we are constructing and interpreting confidence intervals for the populations. The bottom line is we're given a bunch of samples. So, and we have to always, remember I told you, we've got to always check our conditions and assumptions from now on. Okay, so here, random sample, the 10% rule, and the large count condition. I'm going over this kind of fast because in the last video, I know I mentioned this on one of the videos. Okay, here, what happens if the conditions are violated? You can't do it. Okay, here is our formula for the confidence interval in words. And I mentioned the standard deviation of the statistic. The standard deviation of the statistic, which is also known as the standard error. Now, please notice something. That has a bunch of hats. Before, when we did this, there were no hats. And that's because confidence intervals are always based on sample information. You don't have anything about the population. So if you don't have anything about the population, how can you use the P if you do not have it? Here is the formula for the confidence interval. Please remember, this is referred to as a one sample Z interval for the population proportion. So we're saying that I can take these samples and then I can make conjecture about the entire population. As I mentioned, looking at the hat, the hat, the hat, and that's a question that is on the project that you guys are working on. Why the hat? Because we have no information at all about the population. Next, notice I changed this down here a little. What is the critical value? The critical value is Z star. And that Z star is associated with the level C. Now here are values you either have to know or we can find. I showed you in class today that we use our T distribution to come up with our Z star. And I know that seems like, why are we using one distribution to find another? Just because it's easier. They're nice enough to put it here at the very bottom. Okay, so as I mentioned before, level C, confidence level C. Here's your 95% confidence interval. The Z star associated with that, which is called the critical value, is 1.96. Here, the critical value associated with the 99% level C is 2.576. And the other one that is very common is the level C, your confidence interval of 90, and the Z star is 1.645. So as we look at what I've done right here, here's your information. Please notice the non-shaded area is the actual interval. And I'm putting right here in red the interval. Now, those values that I gave you that are here represent this part of your bell. The critical value of a negative 1.96 and a positive 1.96. Here for the 90% confidence interval, a negative 1.645, a positive 1.645. Here, your level C, that's 99% confidence interval, a negative 2.576 and a positive 2.576. Now, those are called, again, critical values. And those critical values are necessary in helping us to come up with our confidence interval. But before we do that, let's talk about the 4 steps. Step 1, state your parameter and your confidence level. Because we're just starting inference, and sometimes we're going to be finding confidence intervals, sometimes we're going to be doing tests of significance. And I need to know, just like the AP reader needs to know, exactly what you are using. Number 2, check for conditions and assumptions. Well, we've said that. I've told you it's coming, in which everything that you do, you need to check your CAs, your conditions and assumptions. Perform the calculations. Perform the calculations is literally just doing your confidence interval and interpreting context. That's not a surprise, is it? So now we can do this in the calculator, and I'm just going to give you guys the instructions for the calculator, but I'm going to have you guys do it by hand, and then tomorrow in class and on the next video, we will literally do it in the calculator. So we are looking for a 1 proportion Z integer. Okay, I said that wrong. A 1 proportion Z interval. So you go to your stat button, go over to test, go down to 1 proportion Z interval. Then once you do that, you'll see this on your screen. You'll see your X, your N, and your confidence level. Your X over N is literally your P hat. One of the biggest mistakes you can make, which happens quite often, is let's say that you're given the probability of success to be 44%. Well, if you put 44%, the calculator gives you an error. Why? Where exactly will the percent goes there? It's telling you that you've got to figure out what the numbers were to get you to the 44%. And like I said, in class, we're going to be doing it together. Now, please take a moment to read number 34. And as you read number 34, highlight key information. Okay, so as we look at number 34, please notice we have an SRS. Thank you. There's one of the conditions of 172. Okay, we're talking about what proportion of the students are willing to report cheating. That is the overall big question. And here, okay, you witnessed 2 students cheating on a quiz. Do you go to the professor? 19 said yes. So we're going to end up with our P hat. Now here, part A says identify the population and the parameter of interest. Well, the population are undergrads at a large university, and your parameter of interest, which is the big picture, is all undergraduate students willing to report cheating. Because remember, what we have right here, we're about to get P hat. Matter of fact, let me write that down right now. P hat is going to equal the 19 over the 172. But based on this information, if I have met my conditions and assumptions, which we will see in a minute, then if it's true for this sample, it's going to be true about this population. And that's what inference is all about. If it's true for the little guys, it's true for the big picture. So check, we've done A. Now we have to check our conditions and assumptions. So here we look at the 10% rule. Please remember, the reason for the 10% rule is to make sure that the sample size is not too big. So honestly, all the undergraduate students at a large university, I don't know what that is, so I'm just going to say all of them, have got to be greater than or equal to 10 times 172. Okay? So, yes, the sample size is okay. Next, SRS, that was a gift. And then here I have to use my large count condition. I can see N times P, which is 172 times 119 over 172 is greater than or equal to 10. I know I could do the math there, but I don't want to. At some point I will, but I don't feel like it now. Just because. No other reason. Okay, here, n times 1 minus p is equal to 172 times. Remember right here, k is just the probability of it not occurring. Yes, it's greater than or equal to 10. Okay, so therefore it's approximately normal. Remember, this large count condition is all about determining, okay, it's normal. So if it's normal, I can use z-score. But I don't have a z-score, but I do need the z-star, which means I need the z-score. Part C, we want to construct a 99% confidence interval. So here, 99%, our z-star is 2.576. I already established our p-hat. And here, as I continue, here is my naked formula. And I'm taking my value for p-hat, taking my value for my proportions, plugging them into the formula. You know that's 1 minus 0.11. Let me make sure that this square root is elongated. So do the math, following your order of operations. That underneath that, your margin of error, I should say. Now, if you notice, I forgot to squeeze in right here my z-star. So here I rewrote it. And once you do the math, follow order of operations and all that good stuff, remember this is your point estimate and here is your margin of error. And of course, once I do that, that gives me my confidence interval, which is 0.05 to 0.17. So that was part D. Sorry, part C. Now part D, I want to interpret the confidence interval in context. Now remember, there are several ways to interpret it. Okay, so here is one way. We are 99% confident that the true proportion is captured. True proportion of, I should say, of the percentage of students who would report cheating will lie within the interval of 0.05 and 0.17. So because here you would not get full credit. So I'm going to have to put like a little, don't want to put an asterisk because z-star has meaning now. So I'm just going to rewrite this. Okay, now let me flip back to what I had originally. You wouldn't receive full credit for this because true proportion of what? Of M&Ms, of, Jolly Ranchers, my food's always on my brain. Or here, in context, remember, we're talking about the students. So here we're 99% confident that the true mean proportion of students, and you don't even have to write down the word mean if you don't want to, of students that will report the cheating is between 0.05 and 0.17. Now, I need to pause a minute. Now I need to correct something I said earlier today. I said that this was wrong, but the reality, it is right. So let's break this down. If this sampling process is repeated many times, check, approximately 95% of the resulting interval, which in this case would be 0.05 to 0.17, would capture the true, and in this case I'm going to say proportion. Now I'm crossing things out, and I'm not crossing things out because I'm saying it's wrong. I'm crossing things out because I'm putting it in context to the particular question that we are doing. Okay, so this is also another way of saying it. Now let's look at the next question. Okay, we're going to skip number 40 because we're going to do it in class tomorrow. And so now let's look at problem number 42. Go ahead and read over that. Highlight the important information. So you may want to pause. Okay, welcome back. Now, as I look at this, a TV poll conducts it's a call-in poll. That's volunteer sampling. I'm not going to call in unless I have an agenda. So the question at the bottom is asking, is the station's conclusion justified? Heck no. It's not an SRS. It's not random. Okay, so tomorrow we're going to do some more examples of this in class. I want you to try to do number 36 on another sheet of paper. And I will just show you the answers really quickly. Now go ahead and read over problem number 36. Now before we look at problem number 36, I need to go back. I noticed that I didn't put my hats. Now remember, everything I have is about the sample. This sample will make conjecture about the population, so got to put on my hat. Okay, now you've taken a moment to read number 36, and as I talk about 36 briefly, as I look at my parts, right here, the population or the parameter of interest is the population of all students or teens who report texting with their friends daily. This is a 1 proportion Z interval for a 95% confidence level. So this is step 1. Step 2 is our conditions and assumptions. Okay, here, teens are randomly selected. The 10% rule is applicable. Here I'm looking at my large count condition so that it is approximately normal. Step 3. As I look at step 3, just reminding myself of what p hat is, here is my naked formula. Notice my hat's all over the place because it's about the same. Being the 95% confidence interval, here we do the math, and here is our conclusion. Now, it's telling me I have storage issues, so I need to stop, and I will see you guys next time. Bye-bye.